So we're not gonna spend a lot of time, but just want to kind of go over some techniques of how you kind of draw shapes in a shader. I think it's more like a so the book of shaders is kind of like dedicated to kind of explaining how you can kind of create all kind of nice graphics inside a shader. I feel it's more like an exercise because it's so easy to like just use multiple tabs or like to like create something. So it doesn't always make sense, but I'm gonna create a new temp called base, and I'm gonna call it procedural drawing. And I'm gonna create a GLSL tab. So now, what if we want to draw a white disk in the center? So let's see how. So if I go back to this, let's say we want to color this pixel, this pixel, this pixel. Oh yeah, so something like this. But the only thing you have for each pixel is the kind of its coordinates in the rectangle. So the way it's gonna work is we're gonna say, oh, for each pixel, I'm gonna calculate the distance from the center of the disk, and if I'm smaller than the radius I want, then I'm gonna be white. But if I'm bigger, then I'm gonna be black. So instead of having something where you're gonna be like, oh, I'm gonna like draw a circle and it's gonna be like a polygon and it's gonna have all these sides. It's like each pixel has to figure out whether it's inside a circle or outside of it. So it's kind of building on the example where we're calculating the distance. So once again, we're gonna say vector2 center. Yeah. I don't know, what do you think? Maybe at this stage, do you want to kind of give it a shot by yourself, like kind of think about 5 minutes, and then like I kind of like walk around and explain? Sounds good? Yeah. Okay, so quick exercise. I'm going to let you think 5 minutes to kind of do this. So I'm going to... So what we want is this, what the circle tab creates for us. So we want to recreate that in code. Gonna give a few pointers. So for each pixel, we want to calculate the distance to the center, and then we're gonna, if the distance is smaller than a certain radius, it's white, and otherwise it's black. So a little note of an if statement. So it works like this. If, and okay, so I'm gonna say float value equal 0.5. And you can do if value is bigger than 0.2. Yeah, and let's define the color first. So So we're going to say the color is black. If value is bigger than 0.2, the color is going to be white. Up. And so now you can see it's true, so I get white. But if my value was 0, now it's false, and I get 0. So it's very simple. If you have like only one line expression, you don't need brackets. But in general, you need brackets. Okay, so now I'm just gonna see. Oh yeah, so some guy did it. Oh, that's weird. Oh, it's just a warning. Yeah. Yeah, just because we're not using. So warning, it's fine. Okay, so congrats to figure it out. And now I'm gonna run through the steps. So I'm gonna call distance. So it's gonna be VUV minus 0.5. So that's the center. Maybe I'm gonna separate this and do big 2 center equal big 2 0.5, and now center. And now I'm gonna say, okay, if distance is smaller than 0.1, and this oh yeah. Okay. So for each pixel, we calculate the distance to the center, and then, so this is like, it's 0.1 in UV coordinates, and if like it's smaller, then we're gonna do white. So So now to make this like a little more flexible, I'm gonna create one uniform called U radius. And in the if statement, I'm gonna replace with U radius, and I forgot to define its type. So since UV goes from 0 to 1, so 0.5 is gonna be the like biggest radius that fits here, because the diameter is gonna be 1, which is like the extent of our square. And so when I animate radius, now you can see I'm like animating Now I'm gonna create a second uniform, which I'm gonna do the same. I'm gonna call it U center. Gonna put it to 0.5 and 0.5, and now I can just replace center by U center. And now I can move, I can both control the radius and move the center.
So Vincent, I have a question.
Yep.
So is it running the if statement for every UV point?
Yeah, so each pixel is running its own if statement.
Right.
Each pixel is like completely unaware of everything else. Each pixel is like, oh, what's my distance to this point? And it's like 0.3, and like, if it's bigger than 0.1, then I'm gonna be white, and otherwise.
Does that mean it runs the main function?
Yeah, for each pixel.
Oh.
Yeah. I think it's something. Yeah, it's really the like thing that's kind of like you have to wrap your head around it when you start doing shader, and that's like different from like traditional programming. Is that each pixel is really like unaware of everything else, and just based on its own coordinates, it has to know which color it is.
And so the vuv.st is the property of that pixel. Or that
Yeah, that is different for each pixel. Yeah. So, yeah, so VUV, it's called contrary to uniforms, which are the same value for the whole, for every pixel. VUV is called a varying, and it means it varies for each pixel.
The VUV is passed in by some kind of a
Yeah,
shader?
it's by the vertex shader. So when we do GLSL tops, this is like kind of created for you and like already available. We're gonna see this afternoon when we deal with 3D how it's passed between the two. Yeah, what you have to be aware is that there's a bunch of code that's like appended to the file you're typing before, but you don't see it. But it's like Touch does it for you.
Does Touch give you the ability to like export the like compiled shader code? Or,
No. I think if you want to port your code to another environment, all the kind of built-in variable, you would have to replace them. So the way you could do that would be to, I mean, you could just use define at the beginning, and then you have like macros that like. I'm gonna show how to convert shader toy shaders to touch, for example. That's gonna like, give you an idea how you like translate things. Yeah.
And how do you set the amount of points in the canvas?
Oh yeah. So by default, it's gonna either take the resolution of the input if you have any input connected. So it's on the command tab, and it's output resolution. So if there's no input, by default is 256 by 256, and otherwise you can do custom resolution and define it yourself.
And it scales at 256 to 0 to 1.
Yeah. So the thing is, for example, right now we're not taking into account the aspect ratio. So if we were to do 512 by 266, then we get a squished circle because it still goes to 0 to 1 and 0 to 1. If we wanted to still have a circle, we would need to take into account the aspect ratio of the canvas. So now that we've seen how to do it with the if function, it's considered not so great practice, but in practice, like you can still use it, and it's not gonna like kill your performance or anything. But there is a built-in function called step, And step does exactly this. So we're gonna,
I think that's how they do it in the book of shader.
yeah. So step, it returns 0. So it takes two arguments, what is called the edge and what is called x. And if x is smaller than the edge, it's return 0, and otherwise it returns 1. So now we're gonna update our code to use step.
So sorry, you were saying that the if statement is slow
It's slower.
or than step? Or
Yeah.
Okay.
Yeah, I would need to. I mean, now that it's easier to see the GPU cook time, it's easier to see if it has any impact. We can. I mean, we can just for practice. So, okay, I'm gonna. So I'm gonna animate the radius. So there is something animated. So I'm gonna do my same silly expression. And do points. And so, so it's 0.03, and if I, and so instead of the if, here I'm gonna do the step, and so it's gonna be color. So the thing is, step only takes, I think it only takes a float argument. So I'm gonna say float inside equals 0, and I'll do inside equal step, the distance, and u radius. And I'm gonna say the color equals fake for inside. And this, and I have a typo here. Still not good. Yeah, so that's the equivalent. Now you can see there is a difference. So I'm gonna do like a lot more pixels, so it's more noticeable. Yeah, so now you can see the version that uses the if statement. We're kind of like 0.1 millisecond, but the version that uses step were 0.005. So it's twice as fast. So it depends how crunch you are, but it depends also if you have other bottlenecks. It's better to use it. But yeah, I think it's already like a trade-off between like code visibility and like optimization and like what's the code legibility, I mean, and optimization. And so, for example, if you want to draw a square, what you can do is like combine multiple step functions. Because you're gonna say, okay, if my x coordinate is bigger than my left edge, then it's white. And then you're gonna have another one. If it's smaller than my right edge, then it's 1. And you're gonna multiply both, and you're gonna do the same for the top and bottom. And that's gonna give you a square. I'm gonna do it quickly. So I'm gonna do float. Oh, sorry. Shouldn't do this. Oops. Cleaning up my open tabs a bit. So the first step to creating like a square, I'm using the x coordinate, and if it's like smaller than like I decided 0.2, it's gonna be transparent. If it's bigger, it's gonna be 1. And now I can, if I want to do the same, but for the right side, I'm gonna do 0.8, but I need to invert it. So now I get this, and so maybe I'll do edge 1, edge 2, and do float square equal edge 1 times edge 2. So now I have the two edges, and now I just need to do the same for the top and bottom. And top and bottom, instead of using the x coordinate, we're gonna use the y coordinate. I'm gonna use x and y instead of x and s and t. And then we multiply all that together. And then if you want a multiple square or more configurable function, you could like wrap that into a function. Maybe let's do that for the circle. And then you can call the function every time you want a square somewhere and specify the center. So quickly, I'm gonna go back to my circle disk. Is everyone, yeah, everyone good with the square? Or
Okay. 1 second.
yep, clear. Any question?
Why we are multiplying the location?
Oh yeah, so I'm gonna go back to show what each one is. So 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 what I call edge 1, it kind of gets rid of this chunk. So what I want is, so edge 2 was getting rid of the right chunk, edge 3 of the bottom chunk, and edge 4 of the top chunk. So when you multiply, it's like white multiplied by white is going to give you white. But if it's transparent and you multiply by white, it's going to be transparent. So this way you combine these different operation and you only keep the intersection, which is the square.
Makes sense. So step is basically like a threshold?
Yeah, exactly. So the thing with step is, so you see it with the circle, is you don't get any anti-aliasing. It's just gonna be 0, 1 based on a pixel. So if you want to have a smoother fall off, a smoother edge, the function you want to use is smooth step. And smooth step, it's gonna like interpolate between two values. And so combining two smooth steps, you can like, I mean, just with one smooth step, you can like have a smaller, kind of a blurry fall off. Bless you. Uh, tu- tu- tu. Everyone is good with the square? Yep. So to kind of explain how to create custom functions, I'm gonna go back quickly to the circle. So the circle is easier to define because you just need to give it like a center and a radius. Like a square, you need to kind of define the 4. I mean, we could also define the center and the width. Yeah, it doesn't matter, but I just do it with the circle. So what you want is, we're gonna define a function called circle, and it's gonna take, so yeah, so float is the return value. It's what the function returns, and we're gonna give it 2 arguments. One is gonna be the center, and the other is gonna be the radius. And yeah, and the third one is going to be the current coordinate. And so we're going to define a value. And we're going to say, so same as we did below, except we want to use the vectors defined for the function. So yeah, so we need to kind of copy this whole block inside. Radius, center. Okay, let me inside and the So radius, of course, it's a float. 29. Oh yeah. Sorry, I haven't actually done that before, so I'm just like improvising. So circle, U center, U radius, and V, UV. And I can okay. So what I did was the code we had before. Now it's inside this function called circle. So a function, it takes different arguments. So they can be like any types. And then when you're inside the function, you can use these arguments to compute the return value. And you have to define, when you declare the function, the first argument, it's the type of the return value. So this function is like, we're providing the center, the radius, and then the coordinate of the current pixel. And we want to return 1 if like we're inside a circle that matches the center and radius, and 0 if we're outside. And so then we can just call it, and we can use the uniform we had defined previously. But the nice thing about doing that is, now if I want another circle, so I'm just gonna stop the animation for a second. Oops. I'm gonna make it pretty small. Now if I want to create another circle, all I need to do, I can do another float called circle2. I don't want to define another uniform, so I'm just going to do vec2.3 at the center. The radius is 0.1. And then you can, I think, just add these two. And so now you get 2 circles. Okay, so yeah. Yeah, so you can define your own function. But all this time we've been using a lot of functions that are already exist in the GLSL spec. So when we use normalized or lengths, we just use existing function that like are ready to use. So there's like a number of useful function you can use that you don't need to recreate.
So you like create your palette of shapes in the top section.
Yeah.
And when you go vec4, that's why lots of code like vec4 is usually pretty tiny, and above it is like this huge section.
Yeah, because you can like have like a pretty big block to define all your function, and then you can combine all these. And it helps with the code readability, because then you can see, oh yeah, I'm doing one circle and another circle, and you don't have to like copy paste this whole block of code, and you can see like to different things. But yeah, I would say this kind of thing is what I was saying earlier is that this is a good exercise to kind of wrap your head around the pixel shader. But in general, if you want to do these sort of things in TouchDesigner, it's going to be more efficient to render circle, like geometric circle. So then if you want to do more complicated thing like blending and shading, I mean, it really depends what you want, but if you can do things with like a render and geometry, it's going to be more efficient because the code right now it is executed on every pixel. So all the black pixels also like kind of run this code. Whereas when you just render geometry, it's like kind of all optimized, and so it's only like running the code on like the pixel that are not empty. So just a quick note. Okay, it's